So the other day I was working, kind of, and I was reading the comment section for an article, and I saw that someone had gone through the article and summarized it. But as I looked closer, I realized that this wasn't a person at all. Someone had written a script or a bot to run through the article and pick out the important points. So I thought, that's pretty cool, and it's actually a decent introduction to one application of machine learning. So today I'm going to show you how to summarize text in Python with the hope of giving you a taste of machine learning that you go out on your own and read about it. So the goal is to write a function that takes in a large body of text, does something, and return one or more summaries of it. And by summaries, I mean just smaller pieces of text that hopefully are representative of the bigger, the original body. So how do we do this? There's probably 100 different ways, but we're going to use an algorithm called text rank. And text rank is nice for two reasons. Number one, it's like 3 steps, so it's really short. And number two, we actually touch on a few different areas related to machine learning. So the steps are, 1, we break our larger text into smaller pieces. 2, we're going to connect these pieces together into a graph. And 3, we're going to find the most important piece. So step 1. The pieces, we're going to break them into our sentences. And initially, I wrote a function to do this, and it didn't work at all because I used regular expressions. So I figured, why not find a library to do this? And I use the NLTK library, which is the Natural Language Toolkit. And it's basically just a bunch of functionality in Python for working with human languages like English, French, German. So specifically, I use their sentence tokenizer. So I just wrap that around my function. So that's step 1. So now that we've broken it into sentences, we have to connect them together into a graph. And if the word graph doesn't ring a bell to you, it's pretty simple. A graph is just a bunch of nodes, so A, B, C, D, and they're all tied together with edges. And these edges are directed, and they have a weight. So an edge with a weight of 8 is 8 times as strong as an edge with a weight of 1. And in our case, our nodes are going to be our sentences, and we're going to connect them together. So the way TextRank wants us to connect our sentences together is just connect every single one to every single other one. So this function basically just runs through all our sentences, creates a tuple with a start and an end, and the similarity is actually the weight of the edge. So that's defined by the number of words they have in common, and then we just account for the length of the sentence, so we don't bias it. So that's step 2. We've connected everything together. Finally, from these sentences and their connections, we have to find the most important piece. And the way we do that is using an algorithm called PageRank. So PageRank is famous for being used by Google. And what they essentially use it for is to rank how important your page is, your website is. So they crawl the internet, they create this huge graph, they run PageRank, and they get some scores back for every website. The higher your score, the more important you are. So we're going to do the exact same thing, except instead of websites, we're going to use sentences. So instead of writing PageRank myself, I downloaded a library again, and I actually downloaded NetworkX, which is Python's library for graphing. So you can create a graph. I did that with digraph. You can add nodes, you can add your edges, your connections, and then you just run statistics on it. So in this case, we ran PageRank. So with those 3 steps, it's done. We take our text in, we break it up into sentences, we connect them together, we rank them, and then we return the top, however many summaries you'd like. So I ran this on a few things. The first thing I ran it on was an article about Adobe, which recently had a breach in security. So it came up with this as a summary for a few page article. So it's a pretty good result, and it kind of covers what the article is talking about. So then I ran it on an article about Twitter's IPO, and I came up with this, which is actually pretty good. It summarizes what the article is about, but the major problem is that it never says Twitter anywhere in the summary. So this is one of the time where the algorithm really didn't work. But after I grabbed the second one, it mentions Twitter, and now it makes a bit more sense. So that's one improvement you can make on the algorithm. Finally, I ran it on green eggs and ham. I got these summaries back. But the reason I'm showing you this one is that I like the last two. So whenever an algorithm makes something by Dr. Seuss sound like something from Blade Runner, I consider it a success. So to conclude, I just want to say 3 things. Number one, machine learning doesn't have to be hard. Right? For example, this one's like 50 lines of Python, and it works pretty well. And it doesn't have to be hard or complex because there are already a ton of libraries, especially in Python. So whenever you can, and I think Steve said this too, you should build upon those because it makes it a lot easier. And number 3, it's good. It solves the problems we couldn't solve before, or it solves them easier or better. So if this is interesting to you, or even if it wasn't interesting to you, go on the Wikipedia, look up machine learning. It's got a ton of uses not related to this, and they're all pretty cool. So that's it. Questions?
Did you use the stopword list, like emit determiners and things like that, like lists and outs?
So I didn't. I don't know what NLTK does. I don't assume they do anything with that function. But yeah, you could pull out all the. So stopwords is just pulling out like the words that really don't have any importance, right? But I don't.
So you got the summaries so that you can do that?
Yes.
That's neat. Cool.
Okay.
Another question?
Is Google supposed to mention information about the PageRank system, or is that really?
Yeah. So it's actually named after. I don't remember the order of the name. Larry Page. Yeah. So when he and Sergey were grad students, I believe, they wrote that. So there's a paper on it. It goes through everything about it. They use more than that to rank websites, and that's like their secret sauce. But this one, you can go on Wikipedia and find the original paper. And I mean, it's not hard to implement, but with machine learning, especially, you can implement something and it seems to be working when really it doesn't, or it fails in some cases. So it's a lot better to use things that have been vetted already.
So you mentioned a couple times that it works pretty well, but the unstated conclusion to that it could work better. So what's like the lowest hanging fruit for an algorithm like that to improve it? Is it the stopwords approach or something like that?
The lowest hanging fruit, I guess it would be to find some sort of metric aside from PageRank that indicates like, are you talking about maybe taking into the title of the article into account? Because obviously if the title is Twitter, maybe we should look for Twitter especially. So that's probably the easiest change you can make, yeah.
So on the examples you provided, what was the runtime for those based on this theorem?
A few seconds. I tried to run it on Mark Twain, and I got bored, so I canceled that. So it's fast, but for a large body of text, it's going to take some time because you have to build a graph out of every single sentence, right? So that's n squared connections, I guess. I hope that's right. Yeah.
Executing this algorithm multiple times, do you always get the same results, or are they different?
Yeah, so I think it's completely deterministic. The only thing that I'm not sure of if PageRank is, but I'm pretty sure it would be. So yeah, you should get the same results every time. And that summary I showed initially, there's some API for it. I think it's called, I don't remember. If we put the slides up, it says at the bottom of it, it's like text view or something. So some company has actually made that available, their API, and that's how they promote themselves. They just run through Reddit's articles. Text processing? Okay. Yeah, so they seem to do it better than I do because they worked on it, obviously. But if you want to do something and you don't want to do it yourself, maybe you could look at that.
Are there like well-regarded algorithms in machine learning that like that you use on in your job, or are the ones that are like would there be a this is a very simple one for classification? Do you know that like any others that would be better but more nuanced for this?
For this specifically?
Yeah.
No. So I don't do this at my day job. I do work on graphs, so we use PageRank, we use various metrics for the graphs. But specifically, we work on clustering, so finding like individuals. So we might take a graph of Twitter users and then run our algorithms on it, and then we find, oh, here's a community, and that's basically the demographics of your graph. But for this specifically,